word equilibrium, what comes to their mind is the state of balance. This is actually correct because balance is a synonym for equilibrium. In our day-to-day activities, it is important that we have balance in whatever we do. For example, as a student, it is important that you set a balance for playing and studying. This is because if you play too much and study too little, your grades in school will suffer. On the other hand, if you study too much to the point that you have little or no time to rest or relax, you may become too stressed. That is why you need equilibrium or balance between playing and studying. In chemistry, equilibrium can also be established or maintained in reversible processes. That is, processes that can proceed in both forward and backward directions. These processes can either be physical or chemical changes. We can define the equilibrium of a system as a state of balance where there are no noticeable changes in a system. This is because the forward and backward processes in the system occur at the same pace. To understand equilibrium better, let's consider some examples of processes that involve equilibrium and some that do not. Burning of wood is a common process which we are all familiar with. The process does not involve equilibrium because it is not a reversible reaction. That is, the ash formed after burning cannot be turned back to the wood. This is also applicable to the burning of paper and the burning of candles, since they are also not reversible. Now let's consider an example which involves equilibrium. In a saturated solution of calcium trioxynitrate 5, shown here, two processes are taking place simultaneously. The first process is the dissolution of the salt, while the second process is the deposition or precipitation of the dissolved salt particles. This system is in a state of equilibrium because the dissolution and the precipitation of the salt particles are taking place at the same pace. In other words, the number of dissolving salt particles is equal to the number of salt particles precipitating. Although the equilibrium here does not involve changes in the composition of the substance involved, reversible chemical changes, which involve the formation of a new substance, can also attain equilibrium. This will be discussed in subsequent lessons. So let's do a recap of what we've learned so far in this lesson. Equilibrium is a state of balance where there are no noticeable changes in a system. Processes that can proceed in both forward and backward directions are called reversible processes. A reversible process can either be physical or chemical change. Equilibrium only occurs in reversible processes. I believe that you've learned interesting things about equilibrium in this lesson. I'd love to see you in the next class.